Hello everybody, welcome back to another video, and in this video we'll be looking at the integrals of sine squared x and cosine squared x. And the first thing we'll look at is the integral of sine squared x, and the way we will do that is we'll essentially have to derive the power reduction formula for sine squared x. So the first thing that we have to do is we have to note, and we can note that, for instance, the cosine of 2x, like so, is equal to the cosine squared x minus the sine squared x in its most direct form, because this directly comes from the summation formula for the cosine, which I proved in my other video using complex numbers. And we know this because we have cosine A cosine B minus sine A sine B, and here we can write this as x plus x. So we get cosine x times cosine x minus sine x times sine x, which is cosine squared x minus sine squared x. So this is what we'll work with. And how do we get the formula for cosine squared x? Well, we already see that we have a linear or a single powered term here and a sine squared x. So we can try and rearrange to solve for sine squared x in terms of these kinds of functions. However, we still see that we have a cosine squared x. So what we do here, we note the second identity, that sine squared x plus cos squared x is equal to 1. And from here, we'll be able to get the power reduction formula, or the reduced power form. So what we see here, we can rearrange for cosine squared x in terms of sine squared x. So with this identity, if we subtract sine squared x on both sides, we see that cosine squared x is equal to 1 minus sine squared x, like so. So if we replace our cosine squared x with exactly that, we see that cosine of 2x can also be written as 1 minus sine squared x and then minus sine squared x. Well, what do we see here? We can combine like terms. We have a sine squared x minus a sine squared x. So that's, yes, a minus 2 sine squared x. So we see that cosine 2x can be equal to 1 minus 2 now sine squared x, after combining like terms. Now, what we can essentially do is we can solve now, finally, for sine squared x in terms of cosine 2x. And we essentially have that done pretty easily, because all we need to do is we need to just add 2 sine squared x on both sides. So cancel and cancel, and now add 2 sine squared x. And what we see here is that we get cosine 2x plus sine squared, or plus 2 sine squared x even, like so. So plus 2 sine squared x is equal to 1. So that is another cool identity. I don't know how useful that will be, but that is an identity, I guess. And what we could also see is that now, if we subtract cosine 2x on both sides, we see that this implies that 2 sine squared x is equal to 1 minus cosine of 2x. And finally, to isolate sine squared x, we have to divide by 1/2. So we divide by 2, and then, or same thing as multiplying by 1/2. So we divide by 2 on both sides, and we see that finally sine squared x is equal to 1 minus cosine of 2x all over 2. So what we've done is we've essentially derived the reduced power form for sine squared x. So what we can do is replace our integrand with exactly that. So what we have now is simply just the integral of 1 minus cosine of 2x all over 2 dx. And this has made it a lot simpler. So what else can we see here? Well, we see that we have everything divided by 1/2. So this can also be written as 1/2 multiplied by all of this. So what we can do, we can see that that's a constant multiple of the integrand, so we can take that out of the integral. So this is equal to 1/2 times the integral of 1 minus cosine 2x, and from now it's pretty standard. So what we can do, you can separate the integral. So this is 1/2 times the integral of 1 dx minus, remember we have to distribute the 1/2, so 1/2 times the integral of cosine 2x dx. And what we can see here, the integral of 1, of course, in the x world is going to be x. So this is equal to 1/2 of x. Now we have to subtract, and then let's figure out what the integral of cosine 2x is. Well, what we can do is we can take a u sub. So we have minus 1/2 the integral of, and then let's say here u is 2x. Therefore, we see that du is 2. So wait, let's just move this over a bit. We'll see that du is 2 dx, and dx is du by 2. So what we can do is we can take that half multiple out of the du by 2, and what we can see here is now we have 1/4. And now we're in the u world, so we're just integrating cosine of u. So let's pick up all of this stuff and move it here. So we'll just make a note that this comes from here. And we'll see that all we're integrating now is the cosine. Our 2x is our u, and our dx is du by 2. We've taken the half out, so all we have is a du here. And guess what? All we have to do is integrate cosine u in the u world, which is, of course, sine. But we know that we still have the sine of u there. So what we'll see that taking this entire thing, we'll see that here we get that this is equal to now 1/2 of x. We still have minus, now we have 1/4 of sine of u. However, what is u? U is 2x. So what we see here is that we finally get 1/2. So let's just write the entire thing. We have the integral of sine squared x dx. That's going to be equal to simply just 1/2 of x minus 1/4 of sine of 2x. 1/4 of sine of 2x plus c. So this is our answer for the first problem. Now, the second problem we'll approach with a similar method. And what we'll see here is that we'll use the second identity to see that, we'll just write this down again, that we want to solve for cosine squared x now. And we know that cosine squared x is equal to 1 minus sine squared x. So all we have to do is we have to use our reduced power form for sine squared x and take 1 minus that, because that is essentially what this identity is stating. So what we have is we have cosine squared x is equal to, and then we have 1 minus, and sine squared x in our reduced power form is 1/2 of 1 and then minus cosine 2x. So what we can see here is we can distribute this 1/2 to each term, and we see that cosine squared x is equal to 1 minus, and then we have 1/2, because 1/2 times 1 is 1/2, minus, and then we have cosine, and then we have 1/2 of cosine 2x. And what we can finally see here is that taking 1 minus all of that, 1 minus 1/2, that's going to be 1/2. So all we have is we have 1/2 minus, and then 1 minus 1/2 of cosine 2x. That is just going to be now plus cosine 2x plus 1/2 of cosine 2x. So of cosine 2x. So what you can see here, that finally our reduced power form for cosine squared x is, then we can factor out the 1/2. It's 1 plus cosine 2x all over 2. So we see that this is the exact same as the sine squared x, except this minus has changed to a plus. And of course, this comes from the fact that we're taking 1 minus that entire expression. So all we have to do the same thing. We have to take the integral. Now we see that the integral of cosine squared x dx is simply equal to the integral of 1 plus cosine of 2x all over 2 dx. Now we see that this half multiple is on everything in the integrand, so we can take that out. So we see that this is equal to 1/2 now of the integral of 1. We can separate the integrals now. We've already done this. So we have the integral of 1 dx, and now this time we add the integral of cosine 2x dx. And now finally we see that this all comes to 1/2 of x. We already found the integral of cosine 2x. That is just that is 1/4. But we still have the one, oh wait, this is a joke. There's still a half multiple here. So what we have here is that this integral evaluates to 1/2 of cosine 2x. So we have 1/2 times 1/2 of sine of 2x. Sine of 2x from our u sub that we did earlier. So what do you see here? Finally multiplying everything out, we see that the integral of cosine squared x dx is just equal to 1/2 x plus 1/2 multiplied by 1/2 is 1/4 sine 2x plus c. And that is our answer to the second problem. And that is pretty cool. And just a note, if you have the integral of some sine of ax, like so, because that is what we had to apply here. That, by definition, will just be, if you take a u sub, set u to be ax, du will be a dx, and dx will be du by a always. So what we see here is we always take a 1 over a, and we're always integrating sine of u in the u world. So this is just going to be 1 over a multiplied by the minus 1 over a cosine of, and then ax. And the same thing, it goes for cosine. When you have the cosine of ax, the integral of that, we can take the same u sub and see that the integral of cosine is sine, so we have the sine of u, which is ax, and we still have our 1/2, or 1a, factored out of that. So this is just a useful formula to know. So what we have here, just a recap of what we did, we proved the reduced power forms for sine squared x and cosine squared x, and we took the integrals of those using a simple u sub problem, and then just some basic integrals to evaluate. So that was it for today's video, and thank you for watching.